friends, so we will be discussing question number 5, 1.1 section from IRODOV, and the question is two particles 1 and 2 moves with constant velocities v1 and v2. At the initial moment, their radius vectors are equal to r1 and r2. How much these four vectors are interrelated for the particles to collide? Okay? So basically, if we assume that particle 1 was at A initially and particle 2 was at B initially, so OA was its position vector, that is R1 given in the question, and OB is its position vector R2 which is given in the question. These two particles to collide, what is important? That it should meet after certain time or in the same time at some point. So let us assume that it meets at C in time t. So AC you can write, because v1 is given, velocity is given, so v1 into time will be AC, right? The same way BC, velocity of particle 2 into time will be BC. Okay? So from the vector law, you can just write, you can see from here, R1 plus V1 into T is equal to R3, that is equal to R2 plus V2 T. Minus V1 into T. How will you calculate T from here? From here, you cannot divide it directly. R1 minus R2 divided by V2 minus V1, because vector does not obey any division law. Means two vectors cannot be divided like A, B. This is undefined. It's wrong. So to get the T is a scalar quantity. So to get the T, you will have to use this equation, but it will go like this. Magnitude of R1 minus R2 vector divided by V2 minus V1 vector magnitude. Putting the value of T in equation 1, R1 minus R2 V2 minus V1 into R1 minus R2 V2 minus V1 magnitude. So this is the relation what in the question it is asking, interrelated for the particles to collide. Hopefully this is clear. So let me tell you one more time. If A vector is there and B is another vector, you writing this way, A divided by B is not correct, because vector does not have any division law. Okay, so this is undefined. So that is the reason for equating T, we took the magnitude of both sides and then we got this. Okay? Any doubt, please write in the comment box. I will come back to it. Thank you.